Okay, here we go. This is a new picture for you, and I just took the time over the weekend to draw this out because this would take forever if I was going to do this. But you can find a picture similar to it on page 819 of your book, okay? So if you go to page 819, whoops, sorry. Didn't like that, did it? How's that? There we go. And take the fill down to 0. All right, so if you go to page 819, you'll find the same thing there. So you don't have to sit there and draw all of this out. Now, if you wanted to go to YouTube, sit there and, take notes on this, just pause it or whatever, that's fine as well. Now, before we've learned some 30, 60, 90 triangles. We learned 45, 45, 90. So those are important angles, 30, 45, 60, okay, and each derivative of that all the way down in here, okay? So what I decided to do, oh, you know what I should have done that I didn't do? Well, we can do it right here, is to show you how to change it from degrees to radians. I should have done that in the first part. That's why I had a minute and a half left over. Okay, so let's do this. Now, over here, pi and 180 are the same exact thing, aren't they? So pi radians is the same thing as 180 degrees. So I could do this. I could say that pi equals 180 degrees. Or I could, yeah, we'll just say it like that. So pi radians, again, I said that you don't have to always put radians with radians, all right? Degrees you need to, with pi, with radians you don't. So 2 pi is 360, all right? So watch, these are equal to each other. Now, just think back to regular math, fractions. When you have something divided by itself, what is something divided by itself equal to? It's equal to 1. So look, these two are equal to each other, aren't they? So I could write it like this. What's that equal to? No, it's not 1 degree. It's just 1. It's just the number 1. Anything divided by itself is 1, all right? So I could write it like this. 180 divided by pi is what? A 1, just the number 1, okay? Not 1 degree or 1 radian, it's just the number 1. Anything divided by itself, let me finish. Okay, anything divided by itself is equal to 1. So watch what I'm going to do. Let's take an easy one, like 30 degrees right here. We'll do that right here. So if I said I wanted to convert, and this is the kind of problems they're going to give you. They're going to give you a lot of these problems. They're going to say, let's take 30 degrees and convert it to radians. So what I'm going to do is I'm going to multiply it. I don't think this book uses this expression, but I did in my other book. In my other school I used to teach out about, and I liked it. It's called a unit multiplier. These are called unit multipliers. Unit because of 1. Multiply because I'm going to multiply that by one of these. Now watch. Which one of these am I going to pick to multiply it? That's right. I want degrees on the bottom, don't I? All right, look, because I got degrees on top, I want degrees on the bottom so they cancel out. So degrees cancel out. So I'm going to put 180 degrees on the bottom and what on the top? Put the pi on the top. Now watch what happens. That goes once. It goes into that. How many times? 6 times. And so what is that? It's pi over 6, just like it is right there. Okay? And I did it for all these angles. I'm not going to go through every single one of them, but you could if you wanted to. And just apply it the same exact way. Let's do it the other way. Let's take a radian. Let's take a real crazy looking radian. Let's take like, I don't know, let's do this one right here. 7 pi over 6, all right? So let's take 7 pi over 6, and let's convert it. And here's some questions they're going to give you. They're going to say, here's something in radians. I want you to convert it to degrees. So we're going to multiply it by a unit multiplier. Which one of these?
The one with pi on the bottom.
That's right. This time we want pi on the bottom because you got pi on top. You want to cancel it with pi on the bottom. So you put pi on the bottom, and you put 180. Do you understand why we can multiply this? Because that's just a 1, isn't it? All right, it's just a unit multiplier. So look what happens. The pi cancels with this, and you work the thing out. That goes once. That goes what? Yeah, so it's 7 times 30, which is 120 degrees. So 7 pi over 6 is the same as, I lied, 120. It's not 120. 7 times 3 is 21. I mixed up the order, all right? So it's 210 degrees. That looks better. So 7 pi over 6 is the same thing as 210 degrees. If you wanted, you could do that with all of these, couldn't you?
Yeah.
All right. Does that make sense to you?
Yeah.
All right. So these are important. Now, am I asking to memorize all these? Not necessarily, because I don't have them all necessarily memorized. Maybe some teachers, some students do. You know, if I said 7 pi over 4, boom, they could tell you 315 degrees. I can't do that, but I could always take a minute or so and figure it out. I'll tell you what, let me show you a little bit of a different way to do this. I think it's a little bit easier. So let's take 7 pi over 4. I just picked that one, no certain reason. And now watch what we're going to do. Instead of multiplying it by 180 over pi, this is kind of easy. If they give it to you in radians, what did we say that pi was equal to? 180. Couldn't I just substitute 180 in for that instead of doing that whole fraction thing? I mean, it's not a whole lot easier, but it's a little bit easier. Okay, so watch. I could go 7 times 180, divide that by 4, and let's see what we get. So let's see. That's not 40. So this is 45, right? 4 goes into 180. Okay, 45 times, and 45 times 7 is? I hope it's 315. Okay, good. All right, it's 315 because 7 pi over 4 right here is the same as 315 degrees. All right, that's not hard at all, is it? All right. That don't like signs. Oh. Yeah, this is more of a basic math kind of concept, kind of a thing. All right. Okay, we good with that? All right. Tell you what, I'm going to pause this. Okay, here we go. Let me get rid of this section right here. Okay, what we're going to do, let me just flip the page here. I think there's only one more thing. Yeah, we're going to use a circle again. And let's use this one again. We'll copy and paste it right here. All right. Now, we did talk about, wrapping around the circle, didn't we? But we talked about the angle, okay? And if I take one radius and I wrap it around the circle, forms an angle. And what's that angle?
1 radian.
1 radian, very good. Okay, so if I take 1 radius and I wrap it around the circle and I join it back up with that center again, it forms an angle. And what is that angle? It's 1 radian. All right, that's the definition of radian. Everybody got that? Okay, now what we're going to do is we're going to talk about, let's draw another, yes.
How many times will a radian wrap around a circle?
Well, you tell me. We talked about it.
Is it
2 pi radians, right?
Is that like a certain number to it or just like a decimal? No.
2 pi. 2 pi radians.
It's 2 pi. It's 6 and a little bit more, right? 6.28 times, it's 6.28 of these will wrap around here, okay? Because, look, to here, 3.14 of those will wrap up to here, okay? So going around all the way, one of these, if I take 1 radius, it'll wrap around 6.28 times, okay? 0.28 times whatever the length of the radius is, okay? All right, 6.28 times around the circle, no matter how big or small the circle is. All right, we got to move on because we're getting close on time here. Let's see. Let's go to my marker here. And what am I doing? Arc length, that's what I want to find. It's arc length. Now, when I talk about the arc length, I'm talking about, now again, it's kind of hard to draw around this thing, but it's a little squiggly. That's terrible. That was, let me see. Let me take a little extra time. Yeah. Oh, there you go. That looks pretty good. All right, look at that. Okay, anyway, we're going to talk not about the angle this time. We're actually going to talk about the length of this thing right here. Now, if this was not 1 radius, then I can't just tell what that is. So let's write this in there. Let's say the radius of this, I don't know, I'm just making this up, is 5 inches. Okay? And what I want to do is I want to find the length of this arc. The letter that they use to represent the length of the arc is S, for whatever reason. You'll find out in physics there's a distance formula. There's a formula that uses distance in there, and they use S, but it's not that distance. It's not the math one. It's something else with velocity and time and stuff. But for distance, they use the letter S a lot. A lot of books do that for whatever reason. So I'm not sure why. Yeah, I don't know why, but they use S a lot. So here's an equation. Now watch. S equals R theta. That's how we find the arc length. But one important thing here, theta has to be in radians. All right, so if that was like 30 degrees, let's just pretend. So that's an easy number to work with. Let's say this was 30 degrees. You're not going to go, oh, S equals the radius times the angle. You're not going to go 30 times 5, 150. If this is 5 inches, there's no way that's 150 inches. Would you agree with that? Yeah, there's no way. All right, so we have to do it a better way than that. And we're running out of time, so let's go one more video. Let's stop.